Next part for Chapter 7 will be short-run production. Here we're going to look at the physical aspects of production in a business. And so we're going to look at data for a variable input. So in the short run, we have two kinds of inputs. We have a fixed input, at least one fixed input, and then we have variable inputs. Variable inputs are inputs that vary based on how much we produce. So if we produce more, we need more of this input. Produce less, we need less of it. When we keep track of our variable inputs, we keep track of them through three different kinds of data collection. And if you talk to any business, I'm sure the owners of the business will be able to recognize these three different kinds of data collection. First of all, simply just the total production, your total product of labor. This represents your total maximum production Q. So total product is nothing more than just Q, how much we're producing. And we're holding our capital and technology constant. And we're going to assume that we're doing the best we can, so we're going to be on a production possibilities frontier. So this would be our maximum production we can get based on the technology, the capital, and the amount of the variable input that we're using. Then we want to keep track of the average product. This is the average amount of output produced by each input, the variable input, and we're going to look at labor as being our variable input. So capital will be the fixed input throughout this chapter, and labor is going to be the variable input. And so any kind of a business wants to keep track of their average product, which they might call in the business their productivity of labor. Output per worker hour, output per worker per day, output per worker per week, and so on. And it's a simple calculation. You use AP for average product, and that would be your total product or your output divided by L, which stands for labor. So if we have, say, we're making 100 chairs per day, and let's say we have, say, 10 workers per day. What is the productivity of those 10 workers? Well, you would take the 100 chairs, which would be your output Q, divided by 10 workers, and that means each of these 10 workers is producing 10 chairs on average. And that'd be 10 chairs per worker. And that way we can quickly see what our workforce is doing, and if we have different production facilities, say in different parts of the country, and this one is showing production of 10 chairs per worker, but the one over, say, in North Carolina is showing 15 chairs per worker, well, we might want to find out why their productivity is higher than the factory out here on the West Coast. And then the marginal product of the variable input, in this case labor, is MP, and this tells us the increase in total product when one more worker is added to production. So if we add one more worker, the marginal product tells us what that worker adds to the business. So it's the increase in output Q when one more worker is added to production. So down here we have a little example. We have a chair factory, so we're talking about chairs. And let's say we have a factory that can go anywhere from 0 to, say, 8 chairs. And let's say these are our total product numbers. And so on the exam, I could ask you to fill in the average product and marginal product columns. So if we have 0 workers, I'm assuming we can't produce anything, right? And therefore the total product is going to be 0. And without any kind of output or any kind of workers to divide the output by, these things are not really something we can calculate, and so they would have no numbers there. If we hire one worker, then say our total product is 10 chairs. This might be per week. And so if you take the 10 divided by 1, that would be average of 10. And then the increase in our total product from when we go from 0 workers to 1 worker is an increase of 10. So with 1 worker, all 3 numbers will be the same, and that's always going to be the case. After that, that will not be the case. So now we have 2 workers, and now our production is 30. So now the average product would be 30 divided by 2, and that would be 15. So that means each of these 2 workers on average is making 15 chairs, and 2 15s give us our 30. And then what did the total product go up by? It went up by 20. So the marginal product is going to be 20. Now, even though we assign the 20 marginal product to the second worker, it doesn't mean the second worker is making all 20 chairs. When we have one worker in the factory, that worker is doing everything, not very productive. You hire a second worker, they can do what economists call specialize, and both can become more efficient. So the second one being there has allowed the first one also to become more efficient. So some of those 20 chairs are being made by the first worker. Nonetheless, we attribute that number to the second worker because that second worker is the reason why the number had gone up by 20. We hire a third worker, our total product goes from 30 to 60. That's an increase of 30. Notice that our margin product is rising. And then you take 60 divided by 3, and that gives us 20. And start to notice there's a connection between the marginal product and the average product. It's like, say, grading exams. If I have 2 exams and say the average score is 15 points, and then I grade a third exam, which is the margin, that's above the average, it's going to drive the class average up, right? So if this number is greater than the previous average, it's going to drive the average up. We go to 4 workers. Now my total production is 110 chairs, which is 50 more than before, and that'll be the marginal product for the fourth worker. That's above the previous average. This number is going to go up. I take 110 divided by 4. I come up with a fraction 27.5. I hire a fifth worker. My total production goes up by 30. That has changed things. Before, my marginal product was rising. We're going to find out that it will rise in most businesses, in most cases, but at some point it will eventually start to fall, the marginal product. Even though it's falling, it's still above that average, right? So if I grade another test score and it's 30 and it's still above the average, even though this score is below that one, the 50, the 30 is still above the average, is going to drive it up still. I take 140 divided by 5, and I get 28. Then my total product goes up from 140 to 160 when I hire the sixth worker. That's an increase of 20. Now it's above the average, previous average, so now it's going to drive it down. You take 160 divided by 6, and you will get about 26.7. Seventh worker increases my production from 160 to 170. It's going to drive that average down. 170 divided by 7 is 24.3. And then number 8 has nothing to do. My total product stays the same, which means my marginal product is 0. If I hire that worker, which would not be too bright, that'd be 170 divided by 8, will bring it down to 21.3. If you can't read my writing, I printed this out. So you can take a picture of that if you want to. Notice that my margin product is going to rise at first. It's going to hit a maximum right there. So here my margin product is rising, and here it's falling. Economists divide those two different areas into two different production classifications. First one is known as increasing marginal returns. As more and more of a variable input, labor in this case, is added to a production process, producing chairs, holding at least one other input constant, capital, the resulting increments of production, marginal product, will many times increase. It's hard to imagine, well, I can imagine some areas. I mean, any kind of manufacturing, you're going to find increasing margin returns. I can maybe see if you have a barber shop, a salon, that if you hire workers, you really can't serve increasing number of customers per employee. So something like services, you may not find increasing margin returns, but most things we can mass produce, you definitely would find increasing margin returns. And that'll be over here on the table. So the way we identify increasing margin returns is when the marginal product is going up. And that's good. Now at some point, this can't go on forever. Well, before I go on to the next classification, I just want to go back and talk more about this. Again, The reason why this happens is because we can specialize. When we had that one worker in the factory by that person's self, that worker was doing everything, and therefore not very productive. We hire two workers that can specialize. One worker can maybe work on the first part of the production of the chairs and pass it on to the second worker. I'll hire a third worker that can specialize even more. One person can sand, one person can assemble, one person can saw. By doing that, you save time from going from one workstation to another. You also become more skilled at what you're doing. And so all these things allow us to specialize more, and that allows production to increase dramatically. This is more like the assembly line, where you divide the task and make an automobile into maybe 40, 50 different tasks. You can increase productivity tremendously through increasing margin returns. And again, the way we identify that is by margin of product going up. And this means output is increasing at an increasing rate. It's accelerating. I'll come back for part 2.